Now we turn to class varying direct effects, where we can also use PSEM, introducing the topic of diff priors that concern comparisons across classes. And we're also going to introduce the align option. And all of this is new for Mplus version 9. So on slide 39 you have the input, and again we're working with the Model 10 setup with 15 direct effects, but now we're going to allow those direct effects to be class varying. So we have the use variables, the 7 indicators, and the 7 covariates. Mixture modeling estimator should be equal to ML here, and with a good number of starts. And we have C regressed on the covariates, and then in the overall model we also have to mention the direct effects, but we're going to focus on the class specific mentioning of the direct effects, so making them class varying. So for instance, for property on sex, black, divorce, age 94, we're going to label them A1 through A4 for those 4 direct effects, and then we continue on adding the numbers for the other direct effects, coming up to 15 direct effects. And for class 2, we then go to label them as B instead of A, going from 1 down to 15. For class 3, we use the letter C, and for class 4, the letter D. So what we have here then is the new setup of do-diff priors. And the do-diff works as follows. We're allowing for class differences for each direct effect, and we're studying those class differences here. We're letting the difference between these classes for these direct effects to have an alpha prior with prior variance 1.0 in this case. So the way you read this, instead of this hashtag here, you put in the number 1 through 15. So first we take a difference prior for A1, B1, C1, D1. So that is comparing the 4 classes. A, B, C are the 4 classes, and the numbers 1 through 15 are the 15 direct effects. So we go first looking at A1, B1, D1, C1. So that is, if you go back one slide, A1 is property on sex in the first class, B1 is property on sex in the second, etc. Property on sex for the 4th class, namely D. Okay, so that's a very convenient way of writing it, and it's not too complicated once you have explained it. Then we have the align output statement here, which is going to compare results across classes for each of these direct effects in a very informative way and concise way. So on slide 41, I take a look at the results for applying class varying direct effects. Again, Model 10 with 15 direct effects now allowed to be varying across classes. So here is the result for the PSEM run with the 1.0 variance for the diff priors. So the diff priors have mean 0 and a variance of 1.0. So we're trying to keep these differences close to the mean of 0 for the prior and rein them in that sense, keeping them to a minimum. And that gives this log likelihood value. BIC is not available because we don't know quite how to compute the number of parameters, as we said before. Now if you do a non-PSEM run with class varying direct effects, you get a likelihood that is better, it's higher, but you get 2 fixed direct effects that could not be estimated. So here we run into the problem of empirical non-identification, which can happen when you do regression of all the indicators on all the covariates, especially when you allow them to be class varying. So in this case, you would prefer the psum run, also because the difference in the log likelihood is not that large. You can do that percent drop in log likelihood calculations that we did before. Now, if you look at the third bullet here then, what about the class invariant case of direct effects using non-psum? Well, that one has no problems of fixed effects, and you get a big value of over here, which you can compare to the non-psum run up here, and you see then that class invariance gets a lower BIC. So the class invariant direct effects is a better model than the class variant direct effects. So better BIC than for class variant direct effects, and no need for class variant direct effects in this example. However, we use this example to illustrate psum with diff priors because that is useful with situations where we do have class varying direct effects. And we're going to take a look at the align option in the output, which shows which effects have significant differences across classes. And that's in line with, that's drawing on the ideas of factor analysis alignment across groups in this 2014 paper and other papers listed at the measurement invariance section of the Mplus website. So on slide 42, you see the alignment option with psum diff priors. And again, let's remind ourselves about what we have here. The letters refer to the four classes, A, B, C, D. And the numbers refer to the direct effects. So if you go back to slide 39 here, you see then that you have A for class 1, B for class 2, etc. And if you look at A1, it's property on sex, the first one of the direct effects for the property item. Going back to 42 again. So we're looking at property on sex comparing the four classes here. Now, first we didn't get a chi-square output here, which is small relative to the degrees of freedom. That is very small class difference in that particular direct effect. So probability is very high that there is no difference. So no significant class differences. So that points towards class invariant direct effects, which the non-psum run with BIC, comparing BICs, also indicated. And we see then out here that we have no significant, no low p-values for any of the comparison, B versus A, C versus A, C versus B, etc. So we're saying then that we're concluding that approximate invariance holds for this direct effect across the classes, and the average value is 0.683. So average of all of these values listed up here. And you have the difference between each here, and you see then that you don't have any significant p-values here. Slide 43 then. Again, letters are classes. We're comparing the four classes. And the number 11, let's go back to slide 40 here. Number 11, that's pot on H94. And we're going to compare that across all of the classes. Back to slide 43 rather. So we're talking about pot on H94 comparing the four classes. And in this case then we have a borderline significance for testing the class differences. And we can then look at where that borderline significance comes from and look at small p-values here. And we see that the smallest one is for comparing C11 and B11. So that's pot on H94 comparing the third and the second classes. And those are the pot and the high classes. So those who are substantive experts here can try to figure out what that means. So that shows you the usefulness of the alignment output in conjunction with the do-diff prior approach.